All right, thanks so much. Excited to be here and share a bit about how agents are becoming more first-class operators within OpenAI and how we're using them to power a lot of internal workflows at the company. All right, so really quick background. So I'm an engineer at OpenAI. I'm part of this future of work effort, which the idea is to take engineering teams and embed them in various functions that are typically non-technical. So we work a lot with user ops, that's customer support, with the people team, and with go-to-market. And we are trying to reimagine how these teams are going to work in an AI native world where a lot of your workflows are AI powered and there are agents that kind of operate alongside you within the company to do real meaningful work. Prior to OpenAI, I was on the AI studio team at Asana. I built their MCP server as one of the early ones that came out last year. And before that, I had stints at Google and Lyft. All right. So overview of what I'll be sharing today. First, I'll talk about how there's been this evolution of LLM usage from narrow-scoped chatbots to applications, now to agents, how that brings us to an interface shift and how we have to rethink how we design systems to not just have UIs and APIs, but also MCPs and other agent interfaces. Some of the things we've learned from operating a lot of these agents and MCPs at scale, so general design patterns and the challenges that pop up in production, and finally, the takeaways and implications for running and building for AI native teams. Okay, so the through line that I would kind of like to draw is that ever since the ChatGPT launch and the evolution of LLMs as a tool, is that first you had the basic chatbot where you could talk to ChatGPT, but your interactions were fairly limited to that chat window. And that was the age of copy-paste from ChatGPT into VS Code or Google Docs, etc. Then we had LLMs as application features, auto-completing your code, generating document drafts, specs, etc. And now finally, we're arriving at agents which can actually take on meaningful chunks of work across different systems. And that interoperability is super powerful. Just some quick highlights of ways that we're using agents internally. Our Slack is absolutely full of agents. They might send as many or more messages than the humans do. So they're in Slack. They can search knowledge bases to answer questions, assist by holding context for ongoing incidents, ongoing sales motions, and codecs can be triggered from Slack to start a pull request with a lot of discussion context. So they really do behave more like teammates once they have all that shared context and communication ability. There's also a lot of great data analysis use cases for text-to-SQL agents that analyze and deep dive into our data sets. The GPT-5 plus family is really good at writing SQL to do that analysis and create dashboards and other artifacts. The development loop is also increasingly getting eaten by codecs and other agents, where code generation, I think everyone is saying, is now cheap, and what the bottleneck is review, verification, etc. So the capabilities here are extending beyond writing the code, and it's really about now how do you test and verify the code? How do you make sure all your tests are passing, how do you monitor deploys and make sure that everything has rolled out properly. And yeah, finally, on the operations side, we have a bunch of co-pilots or sidekicks that can crawl through our SOPs and both suggest actions and suggest updates to knowledge bases when things don't quite line up. So that's a lot of a lot of different use cases, and I'd like to deep dive into one particular one so you get a better sense of all the kind of system components that might be involved. Let's say that a go-to-market sales rep has an important sales call with a CTO or CIO the next day, and they need help prepping for it. So they might engage a go-to-market assistant agent, and how they do that is they have a few different options for entry points, right? They can talk to it on Slack, and that might trigger an agent run. They might use ChatGPT and a remote MCP endpoint, or they might be using a local agent like Codex and also pointing it to either a locally running MCP or a remote MCP endpoint. Now, all of these can access the same core agent and core logic that has access to all of these various internal and external knowledge and systems. So that agent will make its plan, it'll execute tool calls as it goes, and it will talk to a mix of both MCPs and regular APIs where it will pull the latest conversation transcripts with the customer from Salesforce. It will look at Notion and Google Docs for any up-to-date run books or advice on the latest features that the salesperson should highlight. And it can also query our data warehouse to see what are the maybe comparative deal sizes or number of users of other companies in this market segment. And finally, it might also build a profile of this customer just through web search or other external tooling. And now, with all of that knowledge, it can output a pretty rich answer for our hypothetical sales rep. And the outputs here are also going to correspond to the entry point that you use. So Slack messages, I would say, are the most lightweight and easy to set up, but relatively simple. So it would probably answer with a long message report in the thread and maybe a markdown table of something found interesting. But now with all of the ChatGPT apps, MCP apps, dynamic UI is also possible to display just-in-time charts, graphs, etc. And another way I really like to interact with these agents is by running a local agent so that you can output local file system artifacts. So having that, whatever it is, text file, PDF, PNG, etc., right there on your laptop for you to further do work with and edit is really powerful. Now, in doing this substantial work, piece of work that takes multiple minutes, maybe even like up to an hour in some case, the limiting factor is usually an agent's access to all these external knowledge and systems. So in developing these agents, the bottleneck right now isn't really the reasoning or planning or interpretation capability of the core model, but its actual eyes, ears, and hands to access the the world of your company. So the more like production systems that the agent has access to, the more work it can actually get done. Just like a normal employee, if you don't add them to Slack or Google Docs, then they can't really get much done. So that core idea brings me to the idea of the interface shift, which I think a lot of the other speakers today have kind of touched on, which is that in a agent-first world where agents are more co-workers than they are automations or workflows, we have to think about how we design our systems and affordances to let them do their best possible job. In the past, first we had UI for humans. Then we had APIs that were designed for deterministic code to call, and so now we have to think about agent interfaces, so MCPs, skills, and other ways for the models to interact with our systems in a almost squishy and more ambiguous way than you would structure a normal API, because it's more about intent rather than pure capability. And one thing I'd also like to point out is that a lot of times in discussions, folks will ask, especially developers will ask, what's the point of an MCP or an agent interface? Why shouldn't I just let the model use the API? And I think that's fair. If you have a locally running dev environment, you have all your API keys and environment variables, like by all means, like write some skills and let Codex write a bunch of Python scripts. But I would say that like a large majority of users, especially non-technical users, will not be willing or able to set those things up, and that's where MCP really comes in handy as this prepackaged set of capabilities, instructions, capabilities and instructions for the model. And just like how when everyone started making public APIs, they didn't take down their websites or their apps. I think going forwards, as we build more and more agent interfaces, they'll be kind of additive and not subtractive from the total surface area. Cool. In terms of building and working with MCPs and agents, there's already been a lot said about best practices and structuring. So I'll go relatively quickly through these, but I think the main points that we internally and a lot of people externally are converging on are that you definitely want to avoid API dumps. Since APIs are generally structured for a human developer to read through and to kind of chain together into a workflow. The big difference with agents is that every time you have to either decide to call a tool or parse through its output, you're incurring cost in terms of context size and another round of inference. So you want to minimize that as much as possible. So I think the goal here is to aim for both fewer and more intent-shaped tools. So the short example I have here is an API-style set of tools might look like get logs by host, get metrics, get trace by ID for maybe some observability platform. But something better would be map it to what you actually want the agent to do. So investigate latency spike, and then within that tool, you can make all those deterministic API calls in sequence and just give back something more actionable for the model to make use of. And on the output side, well, first, on the input side, you want to avoid 20, 30, 50 tools listed, because the model will have a harder time choosing what to do. That's the whole decision boundary problem. And on the output side, you also probably want to avoid dumping like a 5 megabyte JSON output since you'll eat up your whole context window. And one way to think about it is making your outputs inspectable rather than exhaustive. So think about when you read a large data set in a Jupyter notebook, you might, and you print it out, you might just be looking at the head, first 10 rows, and you operate on that data structure rather than kind of reading the entire thing into memory. The other good points here would be to make use of your existing auth. I think that MCP is just another interface for your system, right? And so there's no reason that you would necessarily need to reinvent your authentication system. If you have user delegation, through OAuth, make use of that. If you have a service account pattern, the same still applies. And there are some situations where you might also want some mixed authentication, where some routes are generally available and harmless, like read actions, versus write or other more sensitive reads. Data exfiltration also becomes a much bigger concern once you're mixing internal and external MCPs. So you want to make sure that the context, whenever a context window contains something sensitive, you don't necessarily want that getting sent outside of your system. Last 2 points here. I would say that another way to kind of encapsulate some of these messy context type of workflows would be to have tools that sub-agent away and encapsulate parts of your workflow, where if a bot that's investigating a outage on one of your services has 3 different things to do, like search through logs, comb through Slack, and comb through recent deploys, you might want to scope those tools and those instructions into sub-agents that just pop simple reusable artifacts back up to the main agent, and that way the main agent doesn't really have to worry about all those additional tools and responses. That does have some trade-offs in terms of orchestration, but we've seen that a general top-level orchestrator with a bunch of subtasks and sub-agents works relatively well. Multi-agent approaches are a little trickier and introduce a lot of complexity around managing state, around managing communication between agents, et cetera. And so it's definitely doable, and I think some people are doing it well. But in my experience, the kind of single orchestrator pattern does tend to be simpler and therefore easier to use and easier to reason about. And lastly, I'd note on skills. Some people are wondering, are skills going to replace MCP? How do they relate to MCP? And my take here is that they're actually generally orthogonal to tools, where the way I think about it is tools are what the model can do. So with the Slack MCP, I can read Slack. With the Google Drive MCP, I can read Google Drive, et cetera. And skills are more how to do things and workflows that can even relate across tools. So a skill could be, here's how you investigate an incident, and so use these different tools in this sequence, right? Or here's how I want you to write a report, et cetera. So I would just imagine them on these 2 different axes of capability versus packaged workflow. I wanted to also talk a little bit more about context economics, since in building MCP, apps and agents, this is usually one of the main sticking points that you run into once you're in production and once you're running longer and longer task rollouts. So we can generally group these into either input or output problems. On the input side, you might be getting tool or server definition overload just from stuffing too many things in. If you configure an agent with 10 MCPs that each have 10 tools, you might be using thousands of tokens and a quarter of your context window before you've even started. And on the output side, I touched on in the previous slide. If you imagine a data analyst agent making a tool call, writing a query to your data warehouse, and all of a sudden you have a 10,000 row CSV that you shove into the context window, that also is not going to go super well. So what are some of the things we can do about this? On the simple side, we can think about generally just pruning out some of those unneeded tools and outputs from the context. So, at runtime, maybe you want to have your own mechanism for tool filtering or progressive tool discovery. On the output side, again, just don't dump the whole JSON or CSV into the output. As far as code execution, there are some really interesting approaches where you can orchestrate and chain tool calls. So if you're familiar, Cloudflare and then Anthropic had the code mode blog posts that they published. Those are good ways of composing tools together where you let the code handle the intermediate output rather than having the model do it. And finally, somewhat related to code execution is this idea of externalized artifacts. So if you're working in a cloud environment you control or on a local agent, pretty topical, I guess, because of OpenClaw, you can actually just really make a lot of use of your file system and write these intermediate outputs and operate on them as files. So again, with the Jupyter Notebook analogy, you don't need to actually have the LLM load everything into its context window. It just needs to know that there is a file with such and such data that exists at this file path, and then it can run a bunch of different operations on it. Okay. The other, I think, big challenge area that we run into in building these agents is debugging model behavior. So as non-deterministic systems, it can sometimes do unexpected things. So it might call the wrong tool. It might call the right tools, but only after 20 steps of trial and error, where it was just calling all the tools until it found the right one. It might silently fail at some point in the workflow. And I think the two main pillars you can rely on here to help you are observability and evals. So on the observability side, just having good hygiene around logging and traces with whichever framework you're using, like OpenAI Agents SDK has traces on the platform, for example. Those can be very useful for looking through model reasoning traces, tool calls, and really just seeing is this just an engineering side problem where the latency of an API was too long, or we had one situation where an API gateway timeout was just set at 15 seconds, and all of our tool calls would just start but stop after 15 seconds, and that was really difficult to debug until we got telemetry flowing through the entire system. And evals, on the other hand, can really surface prompt or context issues, or even core model limitations. And I think a lot of people, say evals, 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 and I wanted to just give a very simple starting recipe here when you're trying to build a workflow. Is take 10 golden tasks where you have the desired input and the desired output, whether it's a report or a SQL query that you want the agent to write, or a tool call you want it to do, and also try and include a couple of frontier tasks. And what I mean by frontier task is something that's actually quite difficult that the current model or workflow cannot yet accomplish. And you can run these before any big changes to your agent or to your workflow. And this will let you, one is really helpful as you build. It's sort of the agent version of test-driven development. But two, also protects you from regressions and kind of lets you build in a way that takes advantage of future model improvement. So I'm sure you've all heard Sam say that the current model you're using is the worst model you'll ever be using. So that is how you can figure out if, when you upgrade to GPT, 5.x or GPT-6 in the future, whether or not you're actually getting a benefit to your workflow. Okay, so the core takeaways that I'd like to leave the room with is that agent interfaces are going to be table stakes in the future. So just like how nowadays, if you're a consumer-facing company and if you didn't have a mobile responsive web page, or you didn't have a good iOS or Android app, that might be kind of a red flag or kind of suspicious. I think that in this future of work that we're entering, we have to really be agent forward, and that's going to unlock so much more capability and productivity with whichever agents you're using, either internal to your company, or that reaches out across multiple different MCPs wherever you do your work. In terms of developing and maintaining these different interfaces for the agents, the capability part is relatively easy. It's an integration problem, but control and observability is really what you should be focusing on. And it doesn't really matter if your agent has access to Slack, right? If it's sending the wrong Slack messages. So the pieces to watch out for here are your context hygiene, are that you should think about workflows rather than APIs, and finally that you should wrap all of this up with your evals and observability. And lastly, the pace of research and progress on core model capabilities, on reasoning, on tool calling, that's only going to get better over time. So I wouldn't worry too much about overfitting to current quirks or limitations, and think about the ways that you can set up your agents to gradually give them more and more autonomy and more long-running tasks. And if you structure it in that way, I think that will give you a really nice runway to kind of keep taking advantage of model capabilities as they keep improving. All right, that is it as far as my prepared content, and yeah, would love to field some questions.
Thank you, Stuart. We'll just take one question.
Yeah.
Which is how to decide between a sub-agent and a skills. In some cases, it's pretty obvious, but not always.
Yeah, so in terms of deciding between a sub-agent and a skill, I think the similarity is that both are kind of probably pre-packaging a set of instructions and tools you want to use for a particular outcome. I think the distinction here probably lies in context management. So if this particular sub-problem that you're trying to solve requires a lot of repeated tool calls and investigating a lot of different contexts, I think that's the point where I would reach for a sub-agent. And there's some artifact you can produce, right, that is pretty independent of the whole reasoning trace. I think that's a good case for a sub-agent. Otherwise, if the skill involves calling, one or multiple Python scripts and not a lot gets put in the context window, yeah, I don't see why you would need the sub-agent approach in that case. Yeah.
Thank you so much.
Okay. Thank you.